Good morning students. In the previous sessions we discussed about ordered pair, Cartesian product and some problems related to ordered pair and Cartesian product. In this class we are going to discuss a new concept, relation. In our daily life we come across so many relations. For example, daughter and father, mother and son, brother and sister, student and teacher and so on. In mathematics also we come across so many relations called mathematical relation. For example, consider A is a subset of B, number 2 is less than 3. Consider line, the line L1 is perpendicular to line L2. The triangle 1 is similar to triangle 2. So these are called mathematical relation. In human relation, for example, consider Radha. Radha is a daughter of Rama. Radha is a daughter of Rama. Here observe, the word daughter shows the relationship between these two persons. Here it connects these two persons. This is called human relation. In mathematical relation, this connects two numbers. So two quantities. Generally we call two elements or two objects. Generally we call elements or object. Now let us understand this concept relation by considering an example. So first consider two non-empty sets A and B. I consider two non-empty sets A and B. A is the set of all elements 0, 2, 4. B is the set of all elements 1, 3, 5. Next, write the Cartesian product of A and B. A cross B is equal to set of all ordered pairs. So Cartesian product. So consider first element in the first set and pair with each element in the second set. 0, 1, 0, 3, 0, 5. Ordered pair 0, 1, ordered pair 0, 3, ordered pair 0, 5. Next, consider second element 2, 1, 2, 3, 2, 5. Ordered pair 2, 1, ordered pair 2, 3, ordered pair 2, 5. Okay, next 4, 4, 1, 4, 3, 4, 5. Ordered pair 4, 1, ordered pair 4, 3, ordered pair 4, 5. Okay. Now consider a relation. Usually relation is denoted by R. Okay. Here I consider relation is less than. Is less than. So now here write the elements. Here elements are ordered pair which are satisfies the given relation or condition is less than. Here a relation introduced between these two elements because in generally we call it connects two objects. Okay. So introduce here and list out which are the ordered pair satisfies the condition or relation is less than. So introduce here 0 is less than 1. 0 is less than 1, true. Therefore ordered pair 0, 1 satisfies the condition, therefore is an element of the given relation R. So next verifier 0 is less than 3, true. Therefore 0, 3 is also an element. Next 0 is less than 5, true. Therefore 0, 5 is also an element of the given relation R. So next 2 is less than 1, false. Therefore ordered pair 2, 1 does not satisfy the condition, therefore is not an element of the given relation. 2 is less than 3, true. Therefore is also an element. 2 is less than 5, true. Therefore 2, 5 is also an element. Next 4 is less than 1, false. Therefore 4, 1 is not an element of the given relation R. 4 is less than 3, false. Therefore it is also not an element of the given relation. 4 is less than 5. It satisfies the condition. Therefore ordered pair 4, 5 is also an element. Okay. Here observe. It contains ordered pair. Here the set A contains 3 elements. The set B contains 3 elements. Therefore Cartesian product contains 3 into 3 total 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. out of 9 elements, only 1, 2, 3, 4, 5, 6, only 6 elements satisfies the condition a relation is less than. Okay. Therefore, here observe, each and every element of R is also an element of A cross B. 0, 1 belongs to A cross B, 0, 3, 0, 5, 2, 3, 2, 5 and 4, 3. All are the elements of A cross B. Therefore, R is a subset of A cross. When we say that it is a subset of another set, each and every, suppose if you want to say A is a subset of B, means each and every element of A must be belongs to B. Then we say that A is a subset of B. If at least one element of A is not belongs to B, then it is not a subset. So here R is a subset of A cross B. R is a subset of A cross B. R is a subset of A cross B. Next, okay, consider one more relation denoted by R1. I consider is equal. I consider one more example defined from A to B. So here relation is equal. Is equal. Here verify. So here no ordered pair satisfies the condition is equal. Therefore the set is empty. The set is null set. So we know that empty set is also a subset of every set, any set. Therefore R1 is also a subset of A cross B. R1 empty set is subset of every set. Therefore R1 is also a subset of A cross B. So consider one more relation. Next example, and that is denoted by R2. I consider a relation is greater than. Is greater than. Now here list out all the ordered pair satisfies the condition the relation is greater than. Introduce here. 0 is greater than 1, false, therefore is not an element of the given relation R2. 0 is greater than 3, false. 0 is greater than 5, false. 2 is greater than 1, true. Therefore ordered pair 2, 1 satisfies the condition, therefore is an element of the given relation R2. 2 is greater than 3, false. 2 is greater than 5, false. 4 is greater than 1, true. Therefore 4, 1 is an element of the given relation R2. 4 is greater than 3, true. Therefore 4, 3 is also an element. 4 is greater than 5, false. Therefore ordered pair 4, 5 is not an element of the given relation R2. So here these 3 elements satisfies the condition R2. Here also these 3 elements also belongs to A cross B. Therefore R2 is a subset of A cross B. So in general, here observe, here we define a relation from A to B. We define a relation from, we consider here 2 non-empty set. Here we define a relation from A to B. So it must be satisfies the condition. First condition, it must be a subset of Cartesian product. If we define any relation from A to B, first condition, it must be a subset of A cross B. Suppose if we define a relation from C to D, I consider 2 non-empty sets C and D. So then first condition, it must be a subset of C cross D. So a relation means a relation is defined from 2 non-empty set. In general we called A and B. Then first condition, it satisfies, it must be a subset of Cartesian product and it contains some ordered pairs. Here observe, out of 9 elements only 3 elements. The relation R2, it contains only 3 elements. So first condition, it is a subset of A cross B. Then it contains some ordered pair which are satisfies the given relation or condition. Here relation or condition is greater than. In first example, R is a subset of A cross B. It contains total 6 ordered pair. Which are the 6 ordered pair? It satisfies the condition is less than. Okay, here R1 is a empty set. Okay. So relation means it is a subset of, suppose if we define a relation from A to B, then first condition, it must be a subset of A cross B. It must be a subset of A cross B and it contains some ordered pair in general. Generalize here. It contains some ordered pair. Here observe, the relation R2, it contains only 3 ordered pairs. In generally, ordered pairs are denoted by A comma B, such that what is A? A means first element. First elements are belongs to first set A. Second element belongs to B, which contains some ordered pair which are satisfying the given relation. It is denoted by A is related to B. A is related to B. Here 2 is related to 1 under the relation is greater than. Here 4 is related to 1 under the relation is greater than. Here 4 is related to 3 under the relation is greater than. Generally, relation is denoted by R. In general, it contains some ordered pair which are satisfying the given relations is true. Is true. This is the definition for relation. So, a relation, if we define a relation from two non-empty sets A and B, it must be a subset of A cross B and it contains some ordered pair which are satisfying the given relation. In generally, we denote like this: A related to B. Here R represents the given relation. It is either greater than, less than or equally, anything. Okay. So, A related to B is true. So, here I consider relation is greater than. In this relation, here 2 is related to 1. Here 2 is called the first element, 1 is called the second element. Here 2 is related to 1, 4 is related to 1, 4 is related to 3. Second element is called the image of the first element. Second element is called the image of the first element. Here image of the element 2 is 1. Image of 4 is 1, image of 4 is 3. So, second element is called the image of the first element. So, first element is called the pre-image. First element is called the pre-image of the second element. Second element is called image of the first element. First element is called pre-image of the second element. Okay. Here we conclude that. So, relation is here we know that relation is a subset of Cartesian product. So, to find out number of relations, from A to B is same as number of relations from A to B is same as number of subset, because we know that relation is a subset from. So, number of relations from A to B is same as number of subsets in A cross B. We know the formula to find out number of subsets is 2 to the power of n. Here n is number of elements in the given set A cross B. So, this is the formula to find out number of relation from A to B. Now, consider the set of all first element and set of all second elements of the ordered pair in a given relation. This is the given relation. Now, consider the set of all first elements of the ordered pair. So, your first elements of the ordered pair are 2, 4, 4. Consider the set of all first element 2, 4. Now, consider the set of all second elements of the ordered pair in a given relation. Our second elements are 1, 3. 1, 3. This is the set of all first elements of the ordered pair. So, this set is called the domain of the given relation R. Domain of the given relation R. Set of all first elements of the ordered pair in a given relation R is called the domain of the relation R. This is the set of all second elements of the ordered pair in a given relation. This set is called the range of the given relation. Set of all first elements of the ordered pair is called the domain. Set of all second elements of the ordered pair in a given relation R is called the range of the given relation R. The second set, because here we describe a relation from A to B. The second set is called the codomain. The second set is called the codomain. Here codomain is B. The first set of all first elements are called domain, set of all second elements are called range. The second set is called the codomain. So, we know that set of all second elements are called range. So, second elements belongs to second set. Here observe 1, 3 belongs to B. Therefore, range is a subset of codomain. Range is a subset of codomain. Sometimes it is also equal to codomain. Okay. We can also represent this relation here. We know that relation is a subset, means relation is a set. We have three representation for a set. In your syllabus we have two methods. One is set builder form, another one is roster form. This is called description method. This representation of a set is called roster form. Set builder form means, in set builder form we represent all the elements by general element by stating their characteristics property. Here generally we denote it by A comma B, such that A belongs to A, B belongs to B. A characteristic property is A related to B is true. A related to B is true. So we can also represent this relation using diagram called arrow diagram, because we represent a relation using arrow, therefore called arrow diagram. So first consider two sets. Here we define a relation from A to B. So usually sets are denoted by circle or closed curves. So here I consider two closed curves, set A and B. Now write the elements of A. A contains 0 to 4, 0 to 4. B means it contains elements 1, 3, 5. Now represent relation using arrow. Okay. So here observe 2 is related to 1. 2 is related to 1 using arrow mark. 2 is related to 1. Next 4 is related to 1. 4 is related to 1. Next 4 is related to 3. 4 is related to 3. So this diagram is called arrow diagram. So relation means it must be a subset of Cartesian product, and it contains some ordered pair which are satisfying the given relation or condition. Next, domain means set of all first elements of the ordered pair. So range means set of all second elements of the ordered pair. Codomain means the second set is called the codomain. Okay. Now let us discuss some examples. And also we discuss in this class image. So second element is called the image of the first element. First element is called the pre-image of the second elements. And number of relations from A to B means number of subsets in A cross B. So formula to find out number of relations from A to B is number of subsets in A cross B, that is equal to 2 to the power of n. Now let us discuss some problems. First one, A is equal to set of all elements 1, 3, 5. B is equal to set of all elements 0, 2, 4. Let R be a relation from A to B given by is greater than. Then find R and domain, codomain, range, and represent in the arrow diagram. Okay. First, find R means find the relation. Here relation is given. Relation is greater than. Means relation in description method. So represent in either roster form or set builder form. Okay. So first find the Cartesian product. So Cartesian product means A cross B. So 1, 0 ordered pair 1, 0. Ordered pair 1, 2. Ordered pair 1, 4. Next 3, 0, 3, 2, 3, 4. Ordered pair 3, 0. Ordered pair 3, 2. Ordered pair 3, 4. Next 5, 0, 5, 2, 5, 4. Ordered pair 5, 0. Ordered pair 5, 2. Ordered pair 5, 4. Now find the relation. Relation is verify here which are the ordered pair satisfies the condition is greater than or not. Okay, 1 is greater than 0, true, therefore ordered pair 1, 0 as an element. 1 is greater than 2, false, is not an element. 1 is greater than 4, false, 3 is greater than 0, therefore ordered pair 3, 0 is an element. 3 is greater than 2, true, therefore ordered pair 3, 2 is an element of the given relation. 3 is greater than 4, false. 5 is greater than 0, true, therefore ordered pair 5, 0 is an element. Next, 5 is greater than 2, true, therefore is also an element. 5 is greater than 4, true, therefore ordered pair 4, 4. Ordered pair 5, 4 is also an element. So this is the given relation. This is also a relation in description method. So this is in roster form. So next write the domain and codomain and range. So domain means set of all first elements of the ordered pair. First elements 1, 3 we have already written, 5. So 1, 3, 5. So next range means set of all second elements of the ordered pair. Second elements 0, 0, 2, 4. So 0, 2, 4. Next codomain. Codomain means the second set. B is called the codomain. Here observe range, in this case range is also equal to codomain 0 to 4, 0 to 4. So range is equal to codomain. We know that range is a subset of codomain. In this case it is also equal to codomain. So now represent using arrow diagram. Using arrow diagram, so consider two sets A and B. So fill the elements of A 1, 3, 5. B means it is the set of all elements 0 to 4. Now represents the relation using arrow. Okay, here observe 1 is related to 0. 1 is related to 0. 3 is related to 0. 3 is related to 0. 3 is related to 2. 3 is related to 2. 5 is related to 0. 5 is related to 0. 5 is related to 2. 5 is related to 2. 5 is related to 4. 5 is related to 4. This is also a representation of the given relation R. Okay, this is called arrow diagram. Okay, next problem. Next problem, second one. Let A is equal to set of all elements 1, 2, 3, 4, 5 and R be a relation on A. R be a relation on A given by R is equal to set of all ordered pair x, y such that y is equal to x plus 1, x and y belongs to A. X and y belongs to A. Then find R, domain, range and codomain. Okay. So here relation is given, here condition is given, y is equal to x plus 1. Find R means find the elements of the given relation, means represent in the roster form. Okay, this relation in set builder form, represent in the roster form. Roster form means list out all the elements satisfying the condition relation y is equal to x plus 1. So here given relation on A means relation is defined from A to A. Here second set is also equal to A. Here the set A contains 5 elements. Second set A means it is also A, it is also contains 5 elements, therefore A cross A, it contains 5 into 5 means 25 elements. Okay. Here equation is given, therefore substituting values for A, directly find out values for Y. Okay. So x means belongs to A, x means first element, belongs to A means x is equal to either 1 or 2 or 3 or 4 or 5. y is also belongs to A means y values of y is also equal to either 1 or 2 or 3 or 4 or 5. So first substitute x is equal to 1. X is equal to 1, then 1 plus 1 2. If x is equal to 1, then y is equal to 2. Therefore out of 25 ordered pairs, ordered pair 1 comma 2 satisfies the given condition. Or suppose if directly verify, first element is 1 comma 1, next 1 comma 2, 1 comma 3. Suppose if you want to verify which are the ordered pair satisfies the condition y is equal to x plus 1 or not, we have total 25 elements. So therefore here by directly substitute values for x and then find out values for y. Okay, 1 comma 2 satisfies the condition out of 25 elements. Next, so consider x is equal to 2. If x is equal to 2, then y is equal to 2 plus 1 means 3. Ordered pair 2 comma 3 satisfies this condition. Next, put x is equal to 3 because x values are 1, 2, 3, 4, 5. Next, substitute x is equal to 3. If x is equal to 3, then y is equal to 4. Next, if we consider x is equal to 4, then y is equal to 4 plus 1, 5. Next, 5 is there. If x is equal to 5, then y becomes 5 plus 1, 6. But we know that y is also belongs to A. The set A contains only 5 elements. 6 does not belongs to A. Therefore, y is not equal to 6. Therefore, the ordered pair 5 comma 6 does not exist. Therefore, in A cross A, we have total 25 elements. Out of 25 elements, only 4 elements means 4 ordered pairs satisfies the condition y is equal to x plus 1. So this is the given relation. Next, domain. Domain means set of all first elements of the ordered pair. First elements are 1, 2, 3, 4. Next, range. Range means set of all second elements of the ordered pair. Second elements are 2, 3, 4, 5. 4, 5. Next, codomain. Codomain means the second set. Here the second set is also equal to A. Codomain is equal to A. Codomain means second set. 1, 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. Here observe. Range is a subset of codomain. Previous example, range is equal to codomain. In this case, range is a subset of codomain. Only 4 elements belongs to this set here. Therefore, it is not equal, but it is a subset. Range is a subset of codomain. Now represent in the using arrow diagram. Consider two sides A and B. A is the set of all elements 1, 2, 3, 4, 5. So here second set is also A. Relation defined from A to A. 1, 2, 3, 4, 5. Now represent relation. 1 is related to 2. Okay, 1 is related to 2. So 2 is related to 3. 2 is related to 3. Next, 3 is related to 4. 3 is related to 4. 4 is related to 5. 4 is related to 5. This is the arrow diagram for the given relation. Okay. So in this class, we have learned relation, definition of relation, domain, range, codomain, and we discuss some problems. Okay. Some problems related to relation. And we will continue in the next class. Thank you.